For this problem, we would like to minimize the surface area of a soda can whose volume is 322 cubic centimeters. So that's what I have drawn here. The two dimensions that you can use to figure out the volume and surface area are the radius of the top circle and the height of the can. I'm just going to start by listing out a couple of formulas. First, the volume of a right cylinder is going to be the area of the top, which is pi r squared, it's a circle, multiplied by the height h. So that's how much space this container takes up. And we're actually told that the volume is 322. So really, I know that 322 is equal to pi r squared h. And this is important. We need a formula that connects r and h so we can solve for one or the other. Now, the surface area, which we are calling S, okay, well, if you look at the top and the bottom, those are, again, both circles whose area is pi r squared, and you have two of them, so the top and bottom give you 2 pi r squared. And then, for the outside part of the can that wraps around, well, the circumference of the circle is 2 pi r times the height h will take care of that part of the can. So that is 2 pi r for the circumference multiplied by h. So that is a formula for the surface area. Our goal is to write this formula in terms of one variable, and they're saying write it in terms of r. If you want to take the derivative of this thing to minimize it, you can't have two variables within the equation. But the good news is you can use this equation to solve for h. It'll be in terms of r, and then you can substitute that in place of this h, giving you a formula completely in terms of r. So that is, I know that 322 equals pi r squared h. You can divide both sides by pi r squared, and this gives you h. It's equal to 322 pi r squared over pi r squared. So to get our formula, I'm going to take this, which is h, and substitute it right here. So let's see, S is equal to 2 pi r squared plus 2 pi r, and again, h is equal to 322 over r squared. And we can actually cancel this r with one of those. If we multiply these two fractions together, we'll have 2 times 322, and that'll give us this 644, and there'll be 1 r in the denominator. So here I was just verifying that this formula is true. S is equal to 2 pi r squared plus 644 over r. This is great. We have a formula written with one variable, meaning we can take its derivative and eventually, hopefully, minimize the surface area. Also, the interval of interest for r is going to be from 0 to technically infinity. R can't be equal to 0 because you can't divide by 0, but the radius of this can only be positive numbers. Okay, we want to find the radius and the height that minimizes this surface area. So what we're going to do is take the derivative of s and set it equal to 0 and solve for the critical points. I think it'd be good to rewrite our function for the surface area as s is equal to 2 pi r squared, and instead of having this r in the denominator, I'm going to move it to the numerator and give it an exponent of -1. So that is 644 times r to the -1. This is the equation that I'm going to take the derivative of. So here's my surface area. I'm taking the derivative with respect to r. So this 2 comes down front and gives me a 4 times pi times r to the first power, which I won't write. For this next piece, I'm going to use the same rule. I'll bring down a -1, which will give us -644 times r, and if I subtract 1 from the exponent, I get -2. And I'm going to set this thing equal to 0 to solve for any critical points. And it'll probably tell us where the minimum value is for the surface area in terms of r. So let's see. If I want to solve this equation, a couple of approaches we could take. First, I'm going to rewrite this so we have a positive exponent. And I'm going to do that by making a fraction and putting r squared in the denominator. So that is, we have 4 pi r minus 644 over r squared is equal to 0. I'm going to multiply both sides by r squared. So I'm going to multiply by r squared. So I'm going to multiply that to every single term on both sides because it'll cancel in the denominator here, taking care of any fractions. When I multiply r squared here, this becomes r cubed. So we have 4 pi r cubed minus, when I multiply r squared to this, we'll have an r squared in the top and the bottom, and they cancel. It'll leave me with 644, and that is equal to 0. All right, I'm going to add 644 to both sides, and that will give me 4 pi r cubed is equal to 644. So I'll divide both sides by 4 pi. So r cubed is equal to 644 over 4 pi. And to solve for r, we're practically there. I'm just going to take the cube root of both sides. So that is, I'll cube root the left, and I'll cube root the right. That means r is equal to the cube root of 644 divided by 4 pi. All right, so I'm going to approximate this value on my calculator because it's asking to round to 2 decimal places. So let's see, cube root of 644 divided by 4 pi. Okay, I'm getting that r is equal to 3.71, and the units on that are going to be centimeters because r is a distance. If we'd like to solve for h, well, we already have a formula that connects r and h. And if you recall, h was equal to 322 over pi r squared. So I'm going to take this number, put it in place of r to solve for h. And I'm going to do this entirely in my calculator. So when I type this in, that's 322 divided by pi times 3.71 squared. So let's see, 322 divided by pi 3.71 squared. Okay, and rounded to 2 decimal places, I get that h is equal to 7.45. And that is also in centimeters. Okay, so these are going to be the dimensions of a right cylinder that will minimize the surface area if you know the volume of the can. For part B of this problem, this was the surface area, the formula, that we got in part A. But it turns out that this doesn't work for an actual soda can, and the reason is it says that the top and the bottom actually have twice the thickness. So what we're going to do is just make a slight adjustment to this formula and then go through the process of finding the critical point based on this new number. So if the top was a pi r squared and the bottom was a pi r squared, that's where this 2 pi r squared came from. So if we're saying that we're doubling both of those, you're basically just going to multiply this by 2. So for part B, the surface area should be 4 pi r squared plus 644 over r. So this is really the only difference, is we're going to make this adjustment in our formula. So here, you're still going to take the derivative and set it equal to 0, and then solve for the value of r in this new equation. It will be different, but the process will be very, very similar.